Hello friends, welcome to the online education. This is the lecture number 5, paper number 502, organic chemistry and spectroscopy. Unit number 2, carbohydrates. Now we have learned about the step-up reaction or Killiani reaction. This reaction have two names, step-up reaction or Killiani reaction. Now, step-up reaction, first we have take the D-arabinose as a reactant. D-arabinose. This is the 5-carbon compound. D-arabinose is reacted with the H2Ni, hydrogen or nickel, and this is the sodium mercury amalgam with a hydrochloric acid. This is the sodium mercury amalgam in the presence of a hydrochloric acid, and it is formed our first intermediate product. This is the mixture of a D-glucononitrile and D-mannonitrile. This is the D-glucononitrile and D-mannonitrile. Our aldehyde group is converted to our cyano or nitrile group, and to form the D-glucononitrile and D-mannonitrile. So D-arabinose reacted with the hydrogen or nickel or sodium mercury amalgam in the presence of HCl and to produce a D-glucononitrile and D-mannonitrile. Now the mixture of D-glucononitrile and D-mannonitrile is reacted with the BaOH twice. This is the barium hydroxide. And in the presence of H2SO4, this is our sulfuric acid. D-glucononitrile and D-mannonitrile is reacted with the barium hydroxide and sulfuric acid, and 1 mole of ammonia was removed and to produce D-gluconic acid and D-mannonic acid. This is the structure of D-gluconic acid. This is the structure of D-mannonic acid. Now our nitrile group or cyano group is converted into the carboxylic group. So this is the D-gluconic acid and this is the D-mannonic acid. This mixture is our second intermediate product. Now D-gluconic acid and D-mannonic acid, on the electronization process we have heat this mixture D-gluconic acid and D-mannonic acid heat. This is the process is the electronization process. This process is a electronization process. One water molecule is removed and to form gamma D mannonolectron and gamma D gluconolectron. This is the gamma D gluconolectron. This is the gamma D mannonolectron. This is the alpha carbon, beta carbon, and gamma carbon. Each combined with the oxygen to our carbonyl group. So this is called gamma D gluconolectron, and this is the gamma D mannonolectron. Also same that this is the alpha carbon, this is the beta carbon, this is the gamma carbon. Oxygen which combined with our carbonyl group and gamma carbon. So this is the gamma D mannonolectron and gamma D gluconolectron. And this is our third intermediate product. Now the mixture of gamma D gluconolectron and gamma D mannonolectron is reduction with the sodium mercury amalgam in the presence of HCl, hydrochloric acid. So this mixture is reacted with the sodium mercury amalgam in the presence of HCl and reduced, and finally we have produced our final product D-glucose and D-mannose. D-glucose and D-mannose. This is the structure of a D-glucose and this is the structure of a D-mannose. D-glucose and D-mannose. Now we have learned about the product D-glucose and D-mannose. This is the 5-carbon product and this is the 6-carbon product. So it is called the step-up reaction. Why this reaction is step-up? Because of the 5 carbon compound D-arabinose is converted into the 6 carbon D-glucose and D-mannose product. So this is called step-up reaction and also called the Killiani reaction. So it is first discovered by the Killiani, and so it is called the Killiani reaction. Now D-arabinose is reacted with the hydrogen and nickel and sodium mercury amalgam in the presence of a hydrochloric acid to form the D-glucononitrile and the D-mannonitrile. Now the glucononitrile and D-mannonitrile is reacted with the barium hydroxide in the presence of H2SO4. One ammonia was removed, 1 mole of ammonia was removed and formed the D-gluconic acid and D-mannonic acid. This mixture of D-gluconic acid and D-mannonic acid each undergo the electronization process, heating, and 1 mole of water was removed and to produce a gamma D gluconolectron and gamma D mannonolectron. The mixture of a gamma D electron and gamma D mannonolectron is reduction with the sodium mercury amalgam in the presence of hydrochloric acid into produce a D glucose and D mannose. So that is the step up reaction or Killiani reaction. So this is the step up reaction because of D-arabinose 5 carbon molecule is converted into the D-glucose or D-mannose is the 6 carbon compound or a molecule. So this is called step up reaction or Killiani reaction. Now we have learned about the Sweden nitromethane reaction. Sweden nitromethane reaction. This is our second topic, Sweden nitromethane reaction. Now we have learned about the Sweden nitromethane reaction. We have first take the D-arabinose molecule. This is also called aldopentose. This is called aldopentose D-arabinose. D-arabinose is reacted with the nitromethane. This is the nitromethane. And this is the sodium methoxide. This is the sodium methoxide. The D-arabinose or also called aldopentose D-arabinose reacted with the nitromethane and the sodium methoxide and to produce our first intermediate product. And our aldehyde group is converted into the CH2NO2 means nitromethane, converted to the aldehyde group converted to the nitromethane combined with our carbon and produce our first intermediate product. Now this intermediate was reacted with the sodium methoxide and 1 mole of methanol is removed and to produce our second intermediate product. This is our second intermediate product. This is the bond was break and CH double bond Na2 minus Na. This is the negative part and this is the positive part of the Na2 minus and Na plus. And this mixture our the intermediate, the second intermediate is reacted with the cold H2SO4. This is the sulfuric acid but in a cold condition and the concentration was the 60%. 60% cold H2SO4 on hydrolysis process and finally we have formed the D plus glucose and D plus mannose. This is our final product D plus glucose and D plus mannose. In this reaction we have used as a reagent nitromethane, so it is called Sweden nitromethane reaction. Sweden was a scientist. It is first discovered by this reaction and it is used the nitromethane as a reagent in this reaction, so it is called Sweden nitromethane reaction. Now let us see D-arabinose is reacted with the nitromethane and sodium methoxide and to produce our first intermediate product, and this product is reacted with the sodium methoxide and 1 mole of methanol was removed and to form our second intermediate product with the double bond of NO2 minus Na plus negative or positive charge particle, and it is mixture of intermediate product is reacted with the cold H2SO4 with a 60% concentration. This process is called hydrolysis, and finally we have produced the D plus glucose and D plus mannose. So this is the Sworden nitromethane reaction, and we have learned about the step up reaction or Killian reaction and also Sworden nitromethane reaction.